Hello everyone and welcome back. In the previous lecture we looked at what generator functions are and how to create generator functions. In this lecture we'll look at some more examples of generators or generator functions. So generators are functions that produce a series of results one at a time, and they use the yield statement. We create them by using the def statement as a regular function, as a normal function, and we just have one or more yield statements in our function. Okay. Let's define a generator function. I'll just name it generator function. Okay, and let's set x to be equal to 1, and let's say print the first value of x is, and then we'll simply yield x, and then let's add 3 to the previous value of x, so x is equal to x plus 3. Then let's print the next, or you can say the second value of x is, and then we'll also yield x, and let's add 5 to the previous value of x, and then we'll print the third value of x is, and we'll yield x, and finally let's add 7 to the previous value of x, and we'll print the last value of x is, and then we'll yield x. Okay, now that we have our generator function, let's call our function generator function, right? And let's save our function in a variable called, let's say, y. So calling our generator function does not execute the function immediately, rather it creates a generator object. So if we call y now, we see that calling our generator function has generated an object, which is a generator object. Now we can iterate through these items. We can iterate through our yield statements in our function by calling the next function. So let's call the next function. So when we call next, the first yield statement will be printed out. So the statement will be printed and then the value of x. So the first value of x is, which is 1, right? So once we call the next function, our function yields the first yield result, and then our function is paused, right? And then the control is transferred to the caller of the function. Now everything is in my hand. So until I call the next function or method again, the function is paused. And when we call the next method again, the function will start running from where it left off last time and then produce the next result, which in this case will be this, right? Print the second value of x, and x is 3 plus 1, 4. So the second value of x is 4. Next, if we call the next function again or method, we'll get the next. So when we call the next function again, we get the third value of x is 9, which is what we have here. The third value of x, and then we got 9, and next we'll add 7 to it. 9 plus 7, 16. And when we call next, when we call the next function again, we'll get 16. So let's call the next function again. We'll get 16. The last value of x is 16. So now that we have all the values from our yield statements, if we call the next method, we'll get a stop iteration error. Great. If we want to call our function again, we have to call our generator function to create a generator object and save that object in some variable. Let's save it in another variable called I, and let's say I is equal to generator function. So now I is a generator object. We can call the next method on it. I.next will give us 1. And another way of calling the next method is as follows. We can simply say next and then pass our generator object I. That will also produce the next yield statement, in this case 4. We can do that also. So the second value of x is 4, and then we can call the next method again by calling next and then passing our generator object. That will give us 9. So next, and then pass I. The last value of x is 16. Now if we call next I, we'll get a stop iteration error. So that's also another way of calling your generator function using the next function. You can either say next and then pass your generator object, or you can call the next method on your generator object. Okay, either way is fine. Great. We can also use for loops with generator functions. So when we use for loops with a generator function, it will produce all the results. Let me show you an example. Let's consider the function that we created in the previous lecture. I think we called it decrease, and then it accepts one parameter while x is greater than 0. Let's yield the value of x. Okay, and then we'll subtract 1 from the last value of x. So let's say this is our generator function. We can use for loops with this generator function. We can say for number in, so we'll pass our function name for number in decrease, and then pass. So this accepts one attribute. Let's say 7. We can say print number. In this case, it will print out all the numbers, 7 through 1. So without this, before I use a for loop, let's see an example by using generator function, right? As we said, when we first call our generator function, it creates a generator object, and we can save it in some variable, let's say I. And then when we call the next method on our object I, we get 7, and then calling the next method on I will give you 6. So it will give us the result one at a time, right? I.next 5, I.next 4, and then 3, 2, 1, and finally the stop iteration error, right? Okay. Now let's see how we can use generator functions with for loops. So as you see here, we can use for loops. As you see here, we can use for loops with generator functions. So what I said here is for numbers, for num in our generator function, and we passed the parameter 7, print the number. So this will print out all the numbers 7 through 1. So let me run it and show you. So when we run it, we get 7, 6, 5, 4, 3, 2, 1. So a for loop takes an iterator and then it iterates over it by using the next function. Similarly, we can use for loops on the example that we created earlier on our generate function example. So here we have our generate function. What we can do is, let me show you the result by using for loops. So we can say for x in our generate function, it doesn't take any arguments. We can say print x. So we are simply iterating through x. So in this case, it will print the first value of x is, and then 4, and then it will print out the second value of x is, and then so on, 4, 9, 16, and so on. Okay, so if we run it, we get the first value of x is 1, and then 4, the third value of x is 9, and finally we have 16. So this is to show you that we can use generators with for loops. Again, a for loop takes this iterator object and it iterates over it by using this next function. Let's look at one more example of generator functions. Okay, let's name it generate and then function. Let's say it takes one attribute and we'll say for, let's say for a in range x, we can say yield a squared if, so our function will yield a squared if it's an even number. So if a modulus 2 is equal to 0, or else it will yield a cubed. Okay, so we have for a in range x, yield a squared if a modulus 2 is 0. That means if the number is even. If not, the result will be a cubed. Now let's call our generator function. So instead of doing that, let me show you how we can use for loops with our generate functions. So we can say for, let's see, for c in range, let's pass for instance 6. For c in range 6, print c for instance, and run it, we get 0, 1, 2, 3, 4, 5, right? So this is a normal function. This is a normal for loop. For c in range 6, print 6. So that means for each number in our list, print each number, right? Now what we'll do is we'll use the same for loop concept and then apply it in our generate function. So we can say for number in our generator function, and then let's pass 6. We can simply print the numbers. So if we run this, so we have this for number in generate function. So here we called our generate function in our for loop. Then we passed 6, right? So 6 will be passed here, and then this for loop will be executed. So for a in range 6, yield a squared if a is positive. So start with 0. If A modulus, if it's positive, it says, if it's an even number, square it. If it's an odd number, cube it. So that's what the generate function does. So 1 cubed is 1, and then we have 0 is 0 when it's 2, when the value of x is 2. 2 times 2 is 4, and then when it's 3, 3 is odd, so it's cubed, 27. When it's 4, it's cubed, 4, I mean it's squared, 4 squared is 16, and then finally when the value is 5, we have 5 cubed. Similarly, we can change this to, let's say, 15, for instance, and run it. We get all the even numbers are squared. So this is 2 squared, 4 squared, 6 squared, 8 squared, 10 squared, 12 squared, and so on. Whereas the odd numbers are cubed. 3 cubed, 5 cubed, 7 cubed, and so on. So this is how we can use the for loop with our generate functions. So by using for loops, we are able to iterate through our generate functions and produce a result. And this is what I have for this lecture, and in the next lecture we'll look at generator expressions. Thank you everyone.